Hello friends, welcome to my channel Civil Smart. Today we are going to design a BBS for a simply supported beam with bent up bar and having a spacers bar at the bottom. These are the spacer bar, right? Because there are two tier in the bottom reinforcement, so we need a spacer bar also. So we need to fill our data in these pink cells only. The accurate data should be filled up as per the requirement, the input data. Then we will calculate the total length of the beam, length of the straight bar cutting length, length of the bent up bar, it will be calculated, and length of the spacer, number of stirrups will be calculated, and the length of the one stirrup will be calculated. Then the bar bending schedule will be automatically given by this sheet, right? So this is for the lower bar, this is for the bent up bar, anchor bar is there, spacer bar, and the stirrup. So now we need to fill up this data. That is the clear span we have given us 6 meter is the clear span, so we need to fill that 6 meter. Beam dimension is 300 by 500, so you need to fill up 300 and the depth is 500, right? So bearing on the walls, this beam is resting on the wall, so bearing, how much the resting length is 200 mm. So 200 mm is the bearing on the walls. Dia of the main reinforcement dia is 20 mm, so we need to fill the 20 mm is here. And the upper tier, so we already know this, the spacer bars are used and the dia or the main reinforcement in the two tier, right? 4 in the lower tier, 4 in the lower tier, so we need to put in the upper tier is 3 in the upper tier, so 3 in the upper tier and 4 in the lower tier. Now the clear cover we assume for the beam is 20 mm. Dia of the spacer bar, we need the spacer bar is there 20 mm and the spacing is 1 meter center to center. So dia of the spacer bar is 20 mm and spacer distance is 1 meter, right? Now the stirrups dia is 8 mm, 2 leg 250 mm center to center. So stirrup dia is 8 mm. You need to fill your dia here. Stirrup dia legged is 2-legged stirrup. We all know that 2-legged, 4-legged and 6-legged stirrups are there. So stirrup spacing is 250 mm. So 250 is the spacing. These are the stirrups, right? So you can see that 8 mm 2-legged stirrups at the rate 250 mm center to center. Now number of anchor bar is these hanger bars are there. Nominal reinforcement, at least 2 numbers are anchor bars should be there. So 12 mm, sorry, these are the number of the anchor bars, so 2 numbers, and the dia of the anchor bar is 12 mm. Now we have filled all the data required for finding out the BBS of this beam. You can see that the detailing part is known over here. So clear span is 6 meters, so 6000 mm, and effective span is center to center distance. So if 200 mm is the bearing length, so this much is 6200 mm. Now you can see that how the difference, like effective length is 6200. Now total length of the beam is clear span 6000 plus bearings 200 over here and 200 over here, 6400. Now the length of the straight bar, this is the straight bar, you can see that this is the straight bar, no hook is there. So length of the straight bar, total length of the beam minus 2 clear cover, one clear cover 20 mm from here, 20 mm from here. So finally the total length of the straight bar, cutting length of the straight bar is 6360, 6.36 in meter. These are in meter, these are in mm, right? Length of the bent up bar, now you can see that this bar is bent up at a L by 7 distance. You know that L by 7 from the support, this is the L by 7, 890. So you can see this bar will be bent up here, so we need to find the length of the bent up bar. So what will be the formula? Length of the straight bar plus 2 into 0.42 h. And what is h? H is this distance, vertical distance, right? So how we can find this h? Minus bend deduction, because 4 bends are there, 1, 2, 3 and 4. All bends are 45 degree bends, right? So you can see that h formula is d minus 2 clear cover. What is d? D is the overall depth minus 2 clear cover from the top and the bottom, minus main bar dia 1 and 2 is the main bar dia, minus spacer bar. So you can see finally you will get the H value, this vertical distance. So this vertical distance is calculated 384. You can see formula is there. Now length of the bent up bar is L. What is L? L is the straight bar length. 6.36 minus 2 into 0.42 H, the formula. H we have already calculated, minus 4 into 1D. Because 45 degree for the bend direction is 1D, so it will be multiplied by minus 4, because one bend direction is here, one is here, one is here, one is here, right? So finally length of the bend bar is calculated. Length of spacer bar B minus 2 clear cover. This is the spacer bar, you can see that. So spacer bar is like this, and this B minus 1 clear cover from here, one. So length of the spacer bar is calculated 0.26, and number of stirrups center to center of the bearing divided by spacing. This is center to center. Effective length divided by the spacing. Spacing is 250 mm center to center plus 1. So number of stirrups is calculated. Length of one stirrup is 2A plus E. What is A? A is the vertical distance and E is the horizontal distance, right? Plus 2 10D. 10D is the hook length, right? 10D is the hook length minus bends. So how many bends? 1, 2, 3 bends are 90 degree and 2 bends are 135 degree, right? So you can see that A is calculated. What is A? This much. Overall DE minus 2 clear cover from the bottom and the top, minus 2 dia of stirrup. Stirrup dia is there, 8 mm the dia of the stirrup. So 2 dia. So you can see A is calculated 444 mm, E is calculated 244 mm. So length of one stirrup is 2A plus E plus 2 into 10D hook length plus minus bend deduction. Minus bend is minus 3 into 2D. 2D for 90 degree. 190 degree second and third. And minus 2 into 3D. 3D is for 135 degree. 2. 1 hook length, 1 second hook length. Right? So all these have been calculated. Now you can see that bar bending schedule. So main bar is lower bar. This much is the straight bar, lower bar. This is the straight bar, lower bar. 20 mm is the dia. 20 mm is the main dia. Number of bars is 4. 4. These 4 are for the bottom. This 4, 20 mm. Length is 6.36. You can see that for the straight bar length is 6.36. Total length is 4 multiply 6.36. Weight for 20 mm d square by 162 is the formula. So weight is 2.47 kg per meter, and the total weight is, you can multiply total length by weight per meter. So 62.81 is the total kg. Upper bar is bent up bar. So bent up bar is 20. Number of bar is 3. You can see that number of bar is 3, and length is 6.6, and total length is this much. Weight in kg, total weight. So anchor bar calculated, spacer bar weight is calculated, and stirrup bar 8. Number of bar is 26, round off. Total length is 1.44 meter. Total length is multiplied by this. Weight 8 kg bar, d square by 162 is 0.40, and all the sum is total is 141 kg is required. At 5% wastage is 7.8. Total weight is 148.76. Now if you change the data, like clear span is 4 meter, B is 300 by 500 or 450, bearing on wall is 300, dia of main reinforcement is 16 mm suppose. Upper dia bar is 3 number and lower dia is also 3 number. Clear cover is 20 mm, and dia of spacer bar is 16 mm or 25 mm. Now you can see all the values has been changed. Length of the straight bar is different, length of the H is different, length of the bent up bar is different, length of the spacer bar is calculated, number of stirrups is different. So bar bending schedule already been calculated by these formulas, and 69.77 kg is required. So this is the bar bending schedule for the condition simply supported beam with bent up bar having the spacer bar at the bottom. So friends, if you like this video, please subscribe my channel, and if you want this Excel sheet, please mail me or WhatsApp me. Thanks.